In this video, we're going to go over the concept of density and how to solve problems using the concept of density. So first, we're going to define what is density. So density is equal to the mass of an object divided by the volume. Okay, so the symbol for density is the Greek letter rho, and the symbol for mass is m, symbol for volume is v. Sometimes it's helpful to solve for mass. If you know the density, you can solve for mass by taking the density times the volume. So let's start with a kind of a classic question that you might hear someone ask you, which is, what is heavier? Okay, so a ton of feather, okay, versus a ton of bricks. What is heavier? So you know that it's kind of a trick question because a ton is telling you the weight, and so they do have the same weight. Okay, so the weight of the feather is equal to the weight of the brick. Okay, however, what's different about these two is their density. The feather has much smaller density, and the brick has a much greater density. So if we were to put a ton of a feather and compared it to a ton of bricks, and we were to put it on some sort of balance here, okay, we would see that the bricks, we would not have too many, but we would have a large volume of feathers. Okay, let's say this is the feathers here. We would have a ton of feathers, a lot, right? Because even though they weigh the same, the feathers are much less dense, and so we're going to need a lot more of them to balance out the bricks. Okay, so let's talk a little bit about units here. So density is, the unit for density is kilograms per cubic meter. And cubic meter is a unit for volume, right? And the mass here is, just as a review, is the unit for mass is kilograms, and the unit for volume is meters cubed. Okay, but that's not the only way to write down the units. Density can also be measured in grams per milliliter, and mass can also be measured in grams, and volume can be measured in milliliter. Here's a chart that you can take a look at that has the different densities for different substances. And one of the things that you'll notice is that as you move from solids, liquids to gas, you'll first notice that the densities actually decrease. Like these are a lot smaller densities than liquids and solids, okay? Because gases, the atoms are much more spread out, molecules much more spread out. And then you can also take a look at the units that are at the top of this chart right here. So the densities can be written in kilograms per cubic meter or grams per milliliter. What is helpful to remember is the density of water. So in a lot of times, problems will require you to know this information. So we're going to take a moment to write this down. So water is 1.00 times 10 to the third kilograms per meters cube, or you can write it as 1.00 grams per milliliter. Okay, so let's take a look at a problem that you might be asked to solve. So we want to calculate the mass of a reservoir. So I'm going to go ahead and draw this reservoir here. Okay, so it's going to look like this. Okay, and let's say that the surface area on top of this reservoir was 50 kilometers squared. Okay, so that's the surface area, and it is 40 meters deep. And we want to find the mass of the reservoir. Okay, so we want to find the mass. What is the mass? Okay, so we're going to first use our density equation, and our density equation is rho is equal to, density is equal to the mass divided by the volume. We're going to rewrite this to solve for mass. So it's going to be the density times the volume. Now we know what the density is for water. Water is 1 times 10 to the third kilograms per meters cubed. Okay, and now we need to multiply it by the volume. So we need to know what the volume is. To calculate the volume, we know that just from math that the volume of a rectangular shaped object would be the area times the height. Okay, so the area we know is 50 kilometers squared. Okay, and we want to convert this to meters. Okay, because notice we have meters here. So we're going to convert this to meters first. So I'm going to take this and multiply it by this conversion factor. I know that 1,000 meter, okay, is equal to 1 kilometer, but I can't just leave it there because notice that that is squared. So I'm going to have to square this whole thing, and this is a common mistake. Students forget to square that, okay? The height of it is 40, okay? And then to calculate the volume, we're going to multiply this, and we get 2.00 times 10 to the 9th meters cubed. Okay, so I'm going to just go ahead and bracket that because I'm going to put that number into my calculation up here. So the volume, take this volume, it's going to go up here, is going to be 2.00 times 10 to the 9th meters cubed. Okay, and sorry about that, but ran out of space, so we're going to go down here. And we calculate that, we get 2.00 times 10 to the 12th kilograms, and that's the amount of mass of water that is in that reservoir. Now let's take a look at another question. Our next question we're going to look at is, what is the volume of 1 troy ounce of pure gold? Okay, so now we're looking for the volume of 1 troy ounce, and a troy ounce is 31.103 grams, okay, of pure gold. Okay. And we're looking for the volume. Okay, so once again, I'm going to start with my density equation. Density equals mass divided by the volume. This time I'm looking for volume. So I'm going to rearrange my equation to solve for volume. It's going to be mass divided by the density. The mass is 31.103 grams. Okay, and then now I need the density of gold, which I can go to my chart, and I see that gold is right here. So 19.32 grams per milliliters. Okay, so I'm going to go to 19.32 grams per milliliter and do a little division there, and I get 1.610 milliliter. Okay. Now, one thing that's helpful in doing these calculations is understanding that 1 milliliter is equal to 1 cubic centimeter. Okay, so these are equivalent. Typically, we'll use these to measure solids, and liquids. We'll use this to measure liquids, to measure volume of liquids, but they are equivalent. So it's helpful to know that because you can also rewrite this. You can rewrite this answer as 1.610 cubic centimeter, and it would mean the same thing. It's the same volume. All right, let's take a look at another question. Now we want to find the density of a rock. Okay, so let's say you have a rock and you want to find the density of this rock. Okay, now to find the density of the rock, you need to know the mass and the volume. Now the tricky part is the volume. Like you can't just measure like the base and the height and depth because it's like irregularly shaped. But what you can do is you could put it in a container filled with water. Okay, and the amount of water it displaces. So you take your rock, you put it in here, and water is going to come out, right? So you catch that water and you measure the amount of volume of that water that comes out. That will give you the volume of the rock. Okay, so the amount of water that this rock displaces, will equal the volume of that rock. So that's kind of an easy way to measure the volume of the rock. So let's say that this rock had a mass of 240 grams. Okay. So we're going to start again with our density equation. Density equals mass divided by the volume, and the mass is 240 grams. And let's say that the volume of the water it displaced was 89 cubic centimeter. Okay, and so once again, you can measure this by the water that was displaced by the rock. Okay, and so we're going to divide by 89 centimeters cubed, and we get 2.70 grams per cubic centimeter, and that is the density of the rock. All right, now let's take a look at another problem where we have a gas tank. Okay, so here we have a gas tank, and the tank is 0.9 meters wide, 0.5 meters tall, and we want to calculate the depth. What's the depth of this tank here? Okay. So we have 50 kilograms of gasoline. Okay. So we know that the gasoline, that when it's filled, has a mass of 50 kilograms. And we want to find the depth. The first thing we want to do is find the volume. So once again, we start with our density equation, which is equal to mass divided by the volume. I'm going to rearrange this and solve for volume. So volume is mass divided by the density, and the mass is 50 kilograms. Okay, now the density, how do we do that? So we're going to have to go to our chart, and we see that the gasoline is 0.68 times 10 to the third kilograms per meters cubed. So going to our chart, we can get that number, that information. So we have 0.68 times 10 to the third kilograms per meters cubed. Okay, so from there we get 0.0735 meters cubed. So that is the volume of the tank, but that's not what we're looking for. We're actually looking for the depth of that tank. The volume is equal to the width of the tank times the height times, I'm going to call capital D here, the depth. Solving for the depth, we get the volume divided by width times the height, and we get 0.0735 meters cubed divided by, and then the width is 0.5. The height is 0.5, and the width is 0.9, and we get 0.163 meters. Okay. All right, we're going to look at one more problem here. So the next problem we're going to take a look at is a coffee mug. All right, so we have a coffee mug, and we want to find out what is the radius of this coffee mug. So here's my coffee mug. Okay. And I know that this coffee mug is 7.5 centimeters tall. I'm looking for the radius of the coffee mug. I know if I fill it up with water, the water would be 375 grams, or coffee, either way. And our density is mass over volume. In this problem, we're going to first figure out what the volume is. Okay, so volume is going to be mass divided by the density. The density is, the mass is 375 grams. The density, we're going to assume that it has the same density of water. Okay, just keep it simple, or you can imagine we're pouring water in there. So it's going to be 1 gram per milliliter, 1 gram per milliliter, and we get 375 grams. Okay, so now that we know what the volume is, and we know that the volume for a cylinder is the area times the length, and we're looking for R, so I'm going to solve for R, and R squared is going to be equal to V, the volume, divided by pi times the L, pi times the length. Okay. So I have a square here, so we got to do a little square root here. Let's square root on both sides, square root on both sides. So we get R is equal to the square root of the volume divided by pi times L. Okay. So the volume is 375, and this should be milliliters. Okay, messed up right there, so that should be milliliters. But we know 1 milliliter equals 1 cubic centimeter, so I can rewrite this as cubic centimeter. And then we have pi here. The L is 7.5 centimeters. And then if we calculate that, we should get 3.99 centimeter, which is the radius of that coffee mug.